Hello class 9, welcome to your geography class. Today I'm going to start your chapter number 4 and the name of the chapter is Earth Structures. So wasting no time, let's get started. Okay, in this chapter we'll read about the three layers of the earth, that is crust, mantle and core. So not only that, we'll come to know about these three layers, their extent and composition. Right children? So wasting no time, let's start our chapter 4, chapter number 4, Earth Structure. Earth's inside structure is quite different to its hard crusty shell, because generally we notice or what we know about earth is like a hard shell, right? But we sometimes get a glimpse of earth's interior through the action of active volcanoes and through the activities earthquake, earth's tectonic plates or earthquakes, right? So interior of earth, we come to know about the interior of the earth through the action of active volcanoes and the movement of crustal movement in the form of earthquakes, right? Now plate tectonics, this is very important term, plate tectonics. Plate tectonics provide a framework for interpreting the composition, structure and internal processes of earth on a global scale. So this phenomena is very important to know earth's actual earth's structure, its like its internal processes and composition, right? Now most of what we know about the interior of the earth comes from the study of seismic waves. So we know seismic waves is what? Seismic waves is a wave which is generated after colliding two tectonic plates. We know inside this earth there are several plates. We can say in general term it's like a that plates are like a slabs. So those slabs, they keep on moving slowly, but at time, at some particular time or sometimes these two slabs or these two plates collide with each other. So in that time when they collide with each other, then a kind of energy release. So that energy is in the form of vibration, and that vibration is seismic waves, right? And which we generally call it as an earthquake, right? Now when an earthquake occurs, the seismic waves spread out in all directions through the earth's interior. These waves contain vital information about the internal structure of the earth. As seismic waves pass through the earth, they are refracted or bent like rays of light bend when they pass through a glass prism. Now I'll show you this with a diagram. Now just have a look. Okay, just see, this is glass prism and light is falling in this direction here on the this prism, and the light here is getting deflected like this, bent or deflected or refracted like this. So this is light, it's bent, refracted light. So same way, when earthquake occurs, the energy released and the energy released in the same way, right? It released and seismic waves pass through the earth. They are refracted or bent like a rays, light of like rays of light bend when they pass through the glass prism, right? Okay, now next, because the speed of the seismic waves depends on density, we can use the travel time of seismic waves to map change in density with depth and show that the earth is composed of several layers. Earth is made up of three concentric layers, And the three layers are the core, the mantle, and the crust. Each layer has its own chemical composition and properties, right? So the intensity of the earthquake depends on depends on the density, depends on the time travel time of the seismic waves. So, and also the depth also, like in density with depth, and show the earth is composed of several layers. So the earthquakes or the earth through seismic waves we come to know earth is having, or earth is made up of three concentric layers, and those three concentric layers are your core, mantle, and crust, right? So and each of these earth's concentric layer made up of its own definite chemical composition and properties. They have their own properties, right? So let's study about these three layers one by one. So first we'll study about the core. Okay, now just have a look in the earth structure. So here are the three concentric layers of the earth. The upper one is your crust. This one, the middle one, is your mantle, and this inner one is your core. So inner one is core. That means the core is having two layers. It is divided into two parts, that is inner core and outer core. So this one is inner core and this is outer core. Right? Okay. Now let's talk about this inner and outer core. We are talking about core now. The core is composed of two layers, as I told you, inner core and outer core. Inner core, outer core. The entire core is about 7,000 kilometer in diameter. So from center it is 7,000 in diameter. Kilometer, 7,000 kilometer diameter. In general, temperature of the core ranges between 4 degrees Celsius to 4,000 degrees Celsius to 6,000 degrees Celsius. That is why this core is having enormous amount of heat and pressure also. So it consists of what? 4,000 to 6,000 degrees Celsius temperature. Occupying the center of the earth, this layer is also called centrosphere. This is at the center of the earth. This layer is at the center of the earth. That is why this is also termed as a centrosphere. Clear? Okay, now. The density of the rocks in this part of the earth is the highest. Density is also highest. Temperature highest. Right? Okay. The major constituents of this layer are metallic minerals, and those metallic minerals are nickel and iron, right? So we know the chemically it is written as nickel Ni, and iron will write it Fe. Ferrous is iron. So NiFe. That is why this core is also known as knife. NiFe, right? Why? Because it consists of two metallic minerals, and those metallic minerals are nickel, Ni, and iron, that is Fe. Clear? Okay. The temperature in the outer core is extremely high, and all minerals melt at this high temperature, but in the inner core, due to great pressure of the overlying strata, the rocks behave like solid rather than liquid material. So this is very important, that this outer layer, outer core is like the temperature is very high, right? And but that inner core is what? Having a high pressure. Inner core having a high pressure. Because of this, outer surface, outer layer, outer core is having high temperature, and inner, there is lot of pressure. Because of this, the center acts as a solid, not liquid, right? Okay. So it's written here, the temperature in the outer core is extremely high and all the minerals melt at this temperature. Whatever the minerals found here, that is in a molten state. All minerals are in a form of, means they found in a molten, or they all the minerals melt at that high temperature of outer core, whereas but the inner core is due to, because of great pressure of this outer core, the inner core acts as a solid rather than liquid material. Clear? Okay, now come to the second layer, that is mantle. So I'll make mantle, this I'll write here M. So this M layer is mantle, right? Okay, the mantle is about 2900 kilometers thick and comprises 83 of the Earth's volume. It is composed of several different layers. So this mantle is, the thickness of mantle is 2900 kilometers, and it is about 83 of the Earth's volume, and it is composed of several different layers. The top layer of the upper mantle, that is 100 to 200 kilometer below surface, that is called asthenosphere. So the top layer of this mantle, we called it asthenosphere. Asthenosphere. Scientific studies suggest that this layer has physical properties that are different from the rest of the upper mantle. The rocks, this upper portion of mantle are more rigid and brittle because of cooler temperature and lower pressure. So rigid means which is breakable, and brittle means which can easily break down into pieces, right? So the upper portion of the mantle acts as like, both the upper portion of the mantle are more rigid and brittle because of cooler temperatures and low pressures. Now below the upper mantle is the lower mantle. Below this upper mantle we have lower mantle, and which extends from 670 to 2900 kilometers below the earth's surface. This layer is hot and plastic, right? The higher pressure in this layer caused the formation of minerals that are different from those of upper mantle. So because of high temperature, the minerals are found here has like a formation of minerals that are different from those of the minerals found in the upper mantle, right? Okay, the lithosphere is a layer that includes the crust and the uppermost portion of the mantle. So this lithosphere is that layer, which consists of the this crust. Now from here crust layer starts. So crust and this uppermost portion of the mantle. Now this layer is about, now next layer we are talking about lithosphere. So we know that lithosphere is what? Lithosphere is the layer which consists of this upper portion of mantle and crust. That is lithosphere. So this layer is about 100 kilometers thick and has ability to glide over the rest of the upper mantle. So this is hard, this layer is hard, that is why it has ability to float on the molten material, that means mantle, right? Because mantle is in a form of semi-liquid form. Because of increasing temperature and pressure, deeper portion of the lithosphere are capable of plastic flow over geologic time. So because of increasing temperature and pressure, deeper portion of the lithosphere, so this deeper portion means here, lithosphere are capable of plastic flow over geologic time. Lithosphere, it is hard, and it has capable of plastic flow. It floats on the this mantle, because mantle acts as a molten or semi liquid. It is in a semi liquid form, right? So this you can also understand like this, if you put a log of wood in the water, then that log of wood will float on the that water surface, right? Because that hard surface always float on a on liquid surface, or liquid on liquid. So the lithosphere is also the zone of earthquakes, mountain buildings, volcanoes, and crust continental drifting. So lithosphere is hard rocks, hard portion. So that lithosphere is a zone, is an area of earthquake, volcanoes, continental drift, mountain building, etc. Right? Okay. Okay, children, I'll take your leave now. In next video, I'll complete this chapter. So after watching this video, you just go through your chapter, read out the chapter, and please send your assignment on time. Otherwise, you lose marks, right? So I suggest everyone to complete the home assignment on time and just send it on time. Otherwise, definitely you are going to lose marks. Clear, children? So I'll take your leave now. Thank you.